So let's take what we did in the last video and we'll build the circuits in Logisim in order to deal with the special cases. So if you go down to the resources section, there's a file called fpm_special_cases. So if you go and open that up and head up to the top level, which is this nnn_test. So double click on that and it'll take you through to this page here. So let's just head down into the multiplier and we'll see the changes that have had to be made. Now the first thing is that there's no changes anywhere else in this multiplier other than in this section here, which is the adder, and this extra section that we've added in called special cases. So let's head down into this section here, which is the adder. Now the only difference we have in this little adder section is that instead of having the demultiplexers here in order to choose the plus and minus value for the underflow and the plus and minus value for the overflow, I've put them into the special cases section, which we'll see just in a minute. But that's the only difference at the top level. The other place where there's a change obviously is this new section here called special cases. So what we do is the original output is this XY, but we're going to take a copy of this output and we take it into the special cases along with the original X value and the original Y value and a few of the other values here as well. And eventually what happens is the value that comes out here is this XY0. Okay, this value here heads down and heads to this point here, and this is the final value. So in effect this is a point where we mentioned the circuit gets broken. So it gets broken here and we put in this special cases before we go to the final output. So let's head down to special cases here. Now you'll see that we've got 3 blocks. So we head into the comparators block first of all. So these are all of the comparators here. You see it just heads off the end of the screen, but there's I'll try and move this in a little bit so you can see it. Okay, so in this section here we've generated all of the test values. So for example we've got the plus infinity for x, plus infinity for y, the not a number for x, plus 0 for x, plus 0 for y, not a number for y, minus infinity x, minus infinity y, minus 0x and minus 0y. Now we generate these simply by taking the x value or the y value and comparing it to each of these. So the 7f8 and 6 zeros is the plus infinity. So we test to say is this plus infinity yes or no, and it'll give you a yes or no output. And if you look at this one, for example the y, you can see that they're all zeros. So the test here in this y value is the y a plus 0, and the answer is yes, because this all zeros is the plus 0 condition, and we get an output. And we also get an output here as well, and it asks us is the 0 plus 0 for x, and the answer here is yes, as it's plus 0 for x as well. So we've got all of these tests that we talked about in the Excel spreadsheet. Now another thing to note here is that we also had tests for just a normal x input, meaning a normal or a subnormal number. But you'll note that there's a little bit of circuitry at the beginning here. Now the reason for this is that we want to put out the value of just a normal value if it's a positive x, so we'll have a plus x, and if it's just a normal or subnormal output and it's a minus x, well this one will go high. If it's a plus y, this will go high. If it's a minus y, this will go high. But of course we've got lots of possible normal and subnormal inputs, and we have to try and define when we actually get a normal or a subnormal input. So one way of doing that here is to ensure that none of the special cases actually have occurred. So we test to say, have any of these special cases here occurred for x, or have any of the special cases occurred for y? Now if none of the special cases have occurred for x, then we know that the input is just a normal or a subnormal number. If none of the special cases have occurred for y, then again we know the input is just a normal or a subnormal number, and we get that through this NOR gate. So this NOR gate will only go high whenever all of these are low. If any one of these are high, then the output here will be a low value, as you see at the moment. So if we imagine that there are no special cases coming in, this would be high. If this is high, you can see here that this point here would be high. And then this would allow us to pass on the positive or negative value for our x straight through to the output. So you can, and I've created this little bit of circuitry here just to do that, just a little bit of combinational logic. And I'll show you what I mean here just now, because I could just put an actual value in. So we'll take this off and we can put this on here. And I'll just call that pin there. I'll just call it I for input. Now we can run through a simulation here. So in this instance, whenever this value here is low, that is that there is actually a special case occurring. It doesn't matter what we do with this pin here, it will always just remain as it was before. So we'll go Control C, Control V. So it's not going to pass this value through. So that value doesn't get passed through here. Now the value will only get passed through whenever the value for this here goes high. So when that goes high, it's now going to pass this value through. And of course it passes it through in the right sense. In this sense here, we've got a 1 passing in, we'll get a 0 passing out. Okay. Now it's the same for each of the rest of them. And again, if you're unsure, you could take the circuit apart and just try it for yourself, and you'll see exactly how each of them work. And these two are slightly different from these two. Okay, so I'll just delete these off so that it doesn't clutter up the rest of our simulation. Okay, so that's us being able to generate all of the values that we need to generate in order to go through the test to find out whether we're actually going to get any particular special case occurring. So we'll head back into the top level here and we'll go to the next part of the circuit. So that's us created all our special case inputs. So now we have to put them together to create the special case outputs. So in effect you can think about this here as being our X and our Y input for all of our special cases. And this part here is going to be the output for them. So for example, if I zoom out here a little bit, well, you can quite see that here. So I'll just zoom back in and then we'll just look at one of them. So we're going to have a plus infinity section here. We'll have another section here which will be a minus infinity section. And then over to the right we're going to have a plus 0, we're going to have a minus 0, and there's also a section over at the right hand side which is our not a number. So I'll zoom right out. So this is our not a number here, and this is just all our inputs. So all we're doing here in effect is this is kind of like our lookup table, but it's a digital lookup table. So what we're doing here, if we take just one of them as an example, so we've got the plus infinity. If I look at this one in terms of our spreadsheet, which we were working on earlier, so we're going to have certain inputs. So these are the inputs that we generated in the last block, so the plus infinity, and the output here, well, we could zoom this in, we could filter on the plus 0, for example, or we'll do plus infinity. We can filter on plus infinity, and we get plus infinity from a plus infinity in X and a plus infinity in for Y. So we've got to test these, and if they're true, then we've got a plus infinity coming out, and we test these ones and these ones. So there's going to be 1, 2, 3, 4, 5, 6 tests. So we'll go back to the original Logisim here. So there's one of the tests here. We'll test this one and this one. So if both these go high, we're going to get a high output, which is a plus infinity. Or this one and this one will go high, or this one or this one, and so on and so forth. So there's 1, 2, 3, 4, 5, 6 tests there. But there's going to be 6 tests for the minus infinity, 6 tests for plus 0, and 6 tests for minus 0. And there's also going to be a whole load of tests here as well for our not a number. Though you won't be able to quite see this because it's quite small, but if you obviously open up the file yourself, you can have a look. And this is the test for not a number. So that's us created all of our tests. So what we're going to do with the test that we've now created, well, if we head back in and we go to the final section here. So the final section is the part where we actually multiplex it onto the output. So again, there's a little bit of work here, but what we really have is our input xy and our final output. Now the path can either be all the way through the multiplier and also straight through here and out through the output. So that would just be a normal multiplication, so multiplying two normal numbers, or a normal with a subnormal and a normal with a normal getting a subnormal, and so forth, the four different cases we looked at. So that would just go through this route here. But if we had a special case, so the special cases are going to be our plus and minus 0, plus minus infinity, and also our not a number, and those are represented by these numbers here. So we're going to choose each of these dependent on whether we get a special case coming through. So we control this from over here. So these are our special cases which came from the last block. So if any one of these special cases go high, you can see again I've got a NOR gate. It means that this point here is going to go low. So if any of special cases are high, this point goes low. So if this point goes low, it means that this value here is going to be low. So it means that we are not going to pass on this value of this particular line here, because this line here will control this output, and this line here will control this output, because we're working through this priority encoder. And as you can see that each of the lines as we work down here controls the output that passes through this mux via each of these lines here. So we know that if any of these inputs are high, then we're going to get a low output. So it means that we're not going to pass this value through here, and we will be passing one of the special cases. Now in this instance here, you can see the special case we're going to pass through is plus 0. And that's hardly surprising. We've got a 0 coming in for x and a 0 coming in for y. You multiply plus 0 and plus 0, you get plus 0, and that's exactly as we would expect. So it means that now we're going to pass the plus 0. So there's the plus 0 here, and you can see we're passing the plus 0 down through this route here. So the plus 0 goes high here, and it's also high here. So it means that this line goes high. That's the third line down, 1, 2, 3, and the third line down is 1, 2, 3, which is the plus 0. So we just pass on plus 0 on the output here. Now the same goes for each of the special cases. If any of the other special cases had gone high, then for example plus infinity had gone high, we would then not pass this value, but we would pass the plus infinity by making this line high, which would make the second line high just via this priority encoder. So we do that for each of these, and this is going to give us our correct output. Now another thing to note is that not only do we require the correct output here, we also require the correct value to come out in our flags. So that's the little red and green circles. We want to be able to flag these up as well. So we can flag these particular values up through the output here. So you can see this plus and 0 is also high here, and it's going to put the output here for the underflow to plus 0. It's going to go high as well. So this is the output we actually take up to the next level up, so that we can see what actual values that the flags we're actually getting. So that's going to control the flags here for these. Now you also have the other option here. Now the other option is that none of these go high, meaning there are no special values. So we know if there are no special values coming through, then it must just be a normal multiplication that's coming through, and the normal multiplications through this route here to the output. So it means if all of these are low, this point here will go high. So if this point goes high, then we're choosing the top line here, and the top line is this line here for the multiplexer and all the way out. So also whenever this goes high, you can see I've got it down through a few AND gates. So it means that in order to, for this, when this goes high here, then each of these AND gates are going to go high. And we've said that all of the special cases have gone low, so we know we're going to get a normal or subnormal multiplication. So the multiplications are either going to be, if the multiplication returns a number which is just not a normal number. So for example, you could multiply plus infinity with plus 0, and plus infinity with plus 0 would give you not a number. So again, this would ensure that we would also have the correct value that would come out here, and also the value would also come out here as well. So you can see here that we're going to be able to pass on all of the values, whether they're the special values or whether they're the normal multiplication values, and we're going to be able to pass them on not only to the output here, we're also going to be able to pass them on to the flags as well. So I suggest what you do in order to see how this works is to just try it out yourself, and you come in at this level and you could take some of these out, and then you could put a little pin in for some of them, and then just toggle the pin, and that will allow you to see the operation of the circuit. So that's all we have for this level here. So let's head back again. So it means that finally what we would have is our final output, which would actually come through this pin here, and this pin is actually connected to the output here. So if you like, the multiplication is coming down through here, the exponent's down through this route, the mantissa's down through this route. We get the final we get the intermediate multiplication here. We take a copy of it, we bring it up here, and we say, right, if there are no special cases, then just pass this value straight to the output. But if there are special cases, then these special cases will supersede anything that's happened in here, and we'll just pass a copy of the special case out to the output instead of the multiplied version. So if you head into the resources section, there's a spreadsheet, so you can go and open that up. There's another tab here on the spreadsheet called Test Script Special Values, so you can click on that tab and it's going to take you through here. So I'll actually zoom in a little bit so we can see it a bit better. So what I've done is I've created a test script for all of the possible inputs for X and Y and all the expected outputs for all of the test cases, and then I've actually gone through the simulation and I've output the actual value from Logisim, and this is the expected outcome here. This is the actual outcome from Logisim, and then I've just done a test that says equals exact, and you compare these two columns C and D. And you can see that when I've worked through it, there were a couple of mistakes I had to fix, but I have fixed them, and these are all true. So all the values are correct. So in order to run through this automatically, what I've done is, if you head into the resources section, you'll see there's another two files there, and it's called MySimX, and there's another file called, I believe it's MySimY. So let's have a little look and see if I can find them here. So they're in point unit, Logisim. So that's the files here, MySimX, MySimY. So I've created those files. Now if you notice that the first line here, it's just got v2.raw. I'll head up the top, you can see this, I don't quite see it. There it is there, v2.raw. So you can just leave that line there as is, and I've copied down the column of all the values, okay? So there's actually 256 of them there. Okay, but there's only a certain number of them have actually got any real values in that we use, but you have to put in all 256. So we've got a file there for X and a file for our Y. And all I've done is I've just copied the column here down into that file for the X and the file for the Y. Now we can head back into Logisim and you can load that file up. There's Logisim here, we go up to the top level and I'll put it on to it looks a bit better, there we go. So we can see here that what we can do in order to run that is we can make sure your little finger is clicked and you can right click this here, edit contents, and you can open a file up. Okay, so that's the file mysimx, so it contains all of the X values for the test. And you can close, and you can do the same here for this, and it's going to create the file, edit contents, and you open up the Y values, so that's all the Y values there. You can close the windows. Now you can just work through this by hand, so we're expecting the first lot to come out and you'll see I go 1, so that's 7f8, so that's infinity times infinity, the same as the value as infinity. And there's another test, and another one, and another one. And you'll see it's working through the test and it's given the required outputs. And you can compare these outputs to what we had in the Excel spreadsheet. And you can also see that the correct flag is being allocated here as well whenever the output type changes. And finally we're working through all the not a number outputs. So that's gone through and it's tested all of the possible special case values for the inputs and the outputs. So that all our special cases now work, and that's quite good because it's now put a little bit of meat on the bones of our multiplier, and we're starting to firm it up a bit, and we're starting to get a good set of numbers coming out. So that's all there is for this video. There's quite a lot in it. I had to admit, I thought it was going to be quite a straightforward and simple exercise to design this, but it actually took me a little bit of time. I'm not sure if there's maybe any quicker or better ways of doing it, because it appeared to me that I wanted to do something that was relatively simple, but whenever I would get into the details of actually doing it, there just seemed to be complications would occur. So take your time and have a little play with it and mess about with the circuits, and if you're stuck and you're still not sure exactly how it's working, you can always get in contact. So thank you for listening. I'll get you in the next video. Goodbye.